Okay, good day. Today we are covering Algebra 2 Lesson 2.2. This is evaluating functions. And by the time you are done with this lesson, you should be able to use function notation to evaluate functions and identify function values from the graph of the function. Now, this video supports the Algebra 2 IXL lessons D3 and D4, which cover the subjects that are in this video. So if you aren't quite ready by the time you're done with the video, and these two IXL lessons, you should be in good shape. Now, I wrote your name, the words your name over here on the right, because we're finding that a number of students, not a lot, but a number of you, aren't getting credit for your IXL skills because your name is not actually being picked up by IXL, and there is a workaround for that. So when you go into skill D3 and D4, you should look in the one of the upper corners. I'm not sure if it's the left or the right, and your name should be there. If it's not, would you go out of that, go back into Clever, go to the blue-green IXL icon, click on it, turn it on, and then when you go back to these skills, your name should be there. And so then you know for absolute certainty, you're going to get the skill recorded grade that you are rightfully entitled to. Okay, and so then I want you to take notes on the lesson in your math notebook. And you'll also explain how you could use what you learned to solve a problem that you think is similar. You're going to upload your notes to me. You may use the Student View Dropbox. If that doesn't work for you for some reason, you can do the default and email it to me at joshua.warren@tusd1.org. You must submit by Wednesday of this next week, 11:59 p.m. Wednesday of next week. So I have pushed this out because we had some difficulties in getting these lessons set on to video form for you, and now I've got them, so you'll have plenty of time to get these things done. Okay? All right, so let's look at the first lesson involved here. Let me grab a sheet of paper. I wrote these out ahead of time, and just want to. I did this for a different class, and so I'm doing it again, and I'm using some of the notes again. So the function of f of x means the function of x. And this says the function of x equals 3x minus 11. Now, most people think this is an equation, okay? And it is, but it's a very different kind of an equation. This is actually your input. This is your input. The x is your input. So here we say that we're going to let f of x equal f of -1. So this is your input. And your input is being put into where you see the x's and you replace them. And so then you have f of -1 equals 3 times -1 minus 11. So here's where things differ. With regular equations, you would be undoing both sides of the equation, and, the equal sign being in the middle. If you took something from one side, you would take it from the other side. You don't do that here. This is really just a signpost telling you what the input is. And all you're doing is putting that in wherever you see in this case, a -1, you replace the x with -1. So you see it here and here. So we rewrite this as f of -1 equals -3, because 3 times -1 is -3, and a -11, and that simplifies to -14. So you're just simplifying the right side, and you're using PEMDAS for this. Use PEMDAS. Not undoing, not SADMAP, okay? So -1 is your input and -14 is your output. And you'll notice this becomes your ordered pair. These are your X and Y coordinates that you could graph, okay? All right. So one of the things I wanted to show you here, just on the bottom, I wanted to show you that sometimes you will see the function of y equals, and then in this case, it would say 3y minus 11. If we were just swapping the x and the y. If that were the case, then this becomes the output, and all of this becomes the input, even though, you know, y itself is an output, okay? So that can happen, but we aren't doing that right now. That just is something for the future. All right. Now, so again, different problem. F of x equals -2x squared plus 3. Oh, it's quadratic. Don't let that worry you. We aren't going to be graphing a quadratic equation. We aren't going to be doing fancy quadratic stuff in the quadratic form. We aren't messing with that. All we're doing, this is a function. Whenever you see f of x or f of whatever the variable is, or g of, because you can use another letter here in place of f, it's just a signpost telling you that this is function. This is a function notation. So whenever you do that and you see that, they always tell you what x is going to be. It's going to be 5 in this case. So f of 5 equals -2 times 5 squared. Okay, so you because you've got exponents here, and the parentheses 5, obviously you can't do anything with that. You go to exponents next. You're going to square the 5 first, and then you'll multiply it times -2, whatever the answer is, and then add 3 to it. So -2 times 25 is -50. You add the 3 and you get -47. So f of 5 equals -47. And so that would mean that your ordered pair would be x is 5, y is -47. So x, y. Okay. All right. Drop my paper here. Okay, so again, up here, I was just showing you that you could, this is g of x. You could call it f of x, you could call it g of x, you could call it h of x, you could call it z of x. You can call it any letter but x or y, that first letter. And it would be, and that's outside of the parentheses, and that would tell you that it is some function. And you're using function notation. So this is all function notation symbols. And just remember, they're just little signposts telling you that you're using whatever is in the parentheses after the letter that's outside of it, that whatever it is, in this case it's 3, is going to be the input that you put in for the variable over here on the right-hand side. So you would write this as g of 3 equals 114 divided by 3 minus 12. Now, most people don't know what 114 divided by 3 is. You can see there it's actually 38. Get your calculator out. So clear it. Type in 114. Oops, that's not 114. 114 and divide it by, in this case, 3. And so 3, and we get, as you can see, 38. And that's what we have here. So 38 minus 12 is 26. You can also subtract the 12 and hit enter, and you get the 26. And so your input is 3, your output is 26, and there's your ordered pair down at the bottom. Okay. All right. So then the last one on this page is a little different. It's an absolute value problem. So with absolute value, you've got to simplify what's inside the absolute value bracket. This bracket is just like parentheses. So you're going to use PEMDAS again, and you will do what's in parentheses first, but you will, because you're evaluating this for t being your x value, if you will, then you're going to replace t with negative 7. So I'm going to write h of negative 7 equals negative 3, and then absolute value of 2 times, and then in parentheses, I'm putting negative 7 minus 5, and then closing the absolute value bracket. Now to simplify this, we got to simplify what's in the bracket. So 2 times negative 7, you would do that first because PEMDAS would say do multiplication before you do, well, first do parentheses, and we did that because we're inside the absolute value bracket, which is a parentheses. But then do exponents, we don't have that, but then you would do multiplication. So 2 times negative 7 is negative 14, and you bring down the negative 5. Now you're going to continue to work in the brackets, so negative 14 and negative 5 is negative 19. All right, now you've got to convert the absolute value number here that's in brackets. Now in previous work that we did on absolute values here earlier in, or at the end of unit 1 actually, we were undoing absolute value equations to solve for the variable. So when you do that, you do something a little bit different. You create 2 equations, one with a positive output and one with a negative output, and then you simplify and solve. Here you don't do that because we don't treat this as an undoing problem. We treat it as a simplification problem, PEMDAS problem. So when you just simply convert your absolute value number, if your absolute value number is negative, you change it to positive, and your brackets become parentheses. So you have negative 3 times 19, and negative 3 times 19 is negative 57. Okay. All right. Now, there is another way to actually simplify an absolute value problem with one of these graphing calculators. So I want to show it to you because it's really good to have these kinds of things available to us. So because we're dealing with an absolute value problem, we're really treating it like an expression problem. So it's going to be negative 3 times the absolute value of 2 times negative 7 minus 5 in the absolute value brackets. But we're going to go, first of all, to a button. Let me clear this. Down here called the math button. You see it? We're going to click that math button. And then it says we're going to go to num. So you look at the top of the math log, and there's num to the right of that. So you have to click the scroll bar here on the right-hand side, and it takes you over to num, and it changes everything. You'll notice number 1 says ABS, and there's a parentheses. So that's ABS, absolute value. Okay. So that's what we're going to do. But before we can do that, we have a negative 3 to deal with. So I'm going to clear this. We're going to take the negative 3. We're going to type that in first. And a negative number, when you start out, it's not an operation number. It's not a subtraction number. You have to use this negative sign at the bottom. So you type negative 3. And so up here it now says negative 3. Now I need the absolute value brackets. So I go to the math button here, click it. I scroll over 1 to get to num. Then I've got ABS as number 1. It's already highlighted. I click enter. And so now you see negative 3 times, when you don't see anything in between a number and something to the right of it, it's multiplication. So times, and then this parentheses is the bracket actually. So we're going to type after that 2, and then t is going to be negative 7. So I'm going to make another parentheses, and I'm going to put negative 7 in. So again, I'm going to go to the bottom, click negative, and then 7. And then I'm going to close the parentheses for the negative 7. And then there was, let's see, negative 5 after it, the t. So remember, negative 7 is t. So I'm going to put minus and then 5. And then I'm going to close the absolute value bracket. When I do that, I then click enter. So I'm going to click enter at the bottom. When I do that, I get negative 57, which is just exactly what my answer was. Okay. All right. I think we have one more page here. Now, so here we're doing something a little different now. Before we were using algebraic expressions, and we were coming up with x and y values. And, I'm sorry, I didn't finish this one. On this one, the absolute value, our input again is -7, our output is -57. So you have -7, -57 is your X and Y values. There's the solution there. Although the solution, technically speaking, is the Y, the output, because that was what they were asking you for. All right, so on this one, you're given a graph. And you'll notice I drew this graph and I've established some points along the line here. And what they want you to do is they want you to evaluate all of these. So they want to know what f of 1 is, what f of 4 is, what f of 0 is, what f of -5 is, and so on. So what we need to do here on something like this is we're going to need to go and figure out on the graph what the x and the y coordinate should be. So this, remember, is f of x. So this is x equals 1. So I go over here to where x equals 1 in this. Remember, this is the x axis. So here's where x equals 1, all right? What is y equal? Well, you have to find where where the line crosses 1 on the x-axis. So I just go straight down, and it's right here. Okay? So where where x is 1, we've got a point down here. And the y coordinate there is -2. So here I'm just going to show you with dotted lines what to expect. Okay, that's how you find. Here's your 1. You go down to the line, and then over here -2. It has to be your output. So you would write -2. Okay, and we'll go on, and so this has to be x equals 4. So I go over here. Here's where x is 4. Go down, and you'll notice that the point's down here. So that's where x is -1. So this is -1. The y is -1. So this is output. Output. Okay. Y equals -2. Y equals -1. Right? Okay. And so then over here, f is 0. So that means x equals 0. So they want to find out what the output or y is. So, by the way, these are your answers up here. So I'm just going to put circles around them. So if x is 0, well, here on the x-axis, x would be 0 right here. So going down, it looks like the y is going to be -3. Okay. So that's your output. So y equals -3. All right, let's find -5. X equals -5. That's your input. So x is -5. So here's -5. So we got to go all the way up here and over here to find out what y is. Y is 4. Okay, so y is +4. Output. Y equals 4. Okay. Okay, now on this one, they say the function of x equals -4. Notice they didn't put the number over here, they put it over here. This is the output side. So this means that y does equal 4. Y equals, or -4 rather, y equals -4. The question is, what is x? That's what they want here. So if y is -4, I got to go down the y-axis, because remember this is your y-axis, to -4 here, and then I got to go over to the line. So I go over to the line, and over here x is, if you go back up, x has got to be -1. Okay, So x equals -1. That's your answer this time. Okay, so that's a trick there. They're trying to, well, it's not a trick, but they're trying to get you to see that they can change the focus of what you're doing from what's the input, or what is the output, to what is the input. Okay, so here again, this is f of x equals 0, so that means this is the output. So y equals 0. Okay. Again, I know that because they put x's over here. They didn't put numbers. Notice the numbers were over here, the inputs, and so that we figured out the outputs by going to the graph. We're doing the same thing here. It's just we know that this is the output we're starting with. So we're going to start with y equals 0. Okay, well, y is 0 anywhere along the x-axis, right? Anywhere along here, y is 0. So I notice that the line crosses the x-axis where y is 0 over here where x is 3. So I got x equals 3, it's input, but I got a second one because if I go over here, I've got one right here. And that looks to be about 4 1/3. So x equals 4 1/3. Okay. So this time there are 2 answers, 2 input answers. Now, does that mean this is not a function? What's the rule on functions? A relation is a function if each input has only one output. And remember when you graph, with graphing, just use the vertical line test because it shows one input for each output. So wherever I draw a vertical line through this, you can see, now, you know, we're good. We only have one output for each input. Let's look at the 3 and 4 1/3, -3 and 4 1/3. So that's right here. And then this one's the other one. So these are vertical line tests. So here there is only one output, 0, for the input 4 1/3. There's only one output, 0, for the input x is -3. So that is a function. It's okay to have more than one output for any given input. That's okay. You still have a function because of the vertical line test and because of what we've been saying, only one one output for each input. Okay. All right, so that's basically it. And vertical line, I didn't lost my eye there. Okay, so we're done, and you have a great rest of your afternoon. We'll talk to you later. Thank you very much.